Broadcasters are pushing for higher efficiency, lower operating costs, and rock-solid on-air reliability. And liquid cooling is playing a major role in making this happen. In today's episode, we break down the 25 years of liquid cooling innovation from early high-power RF cooling concepts, to today's fully integrated high-density transmitter platforms. We explore how modern systems eliminate galvanic corrosion, /HVAC loading, and they boost power density and dramatically simplify maintenance. And for Rohde and Schwarz, it all started back in 1999 when pairing high power RF with water was considered a bold and even risky move. And yet liquid cooled UHF and VHF amplifiers quickly proved their value, unlocking dramatic jumps in power density with every new transmitter generation. And by 2007, the NV8600 brought a redesigned pump unit that would set the foundation for years to come. In 2011, the TH9 series advanced that foundation even further with integrated coolant distribution modules, eliminated long hose runs, and significantly improving reliability. And most recently at NAB in 2024, the T1 transmitter family pushed density and efficiency to new height levels with the latest generations of silicone and fully software-based exciters. Across these generations, one theme holds true: when a liquid cooling system is engineered correctly, the impact on reliability, cost, and maintenance, it's enormous. So what defines a reliable liquid cooling system? It starts with a closed-loop pressurized design. No oxygen, no contamination, and no evaporative loss. Get these fundamentals right, and the benefits speak for themselves. No scheduled coolant changes, no fans inside the amplifiers. We're talking about silent operation and minimal maintenance, and maximum durability. A properly designed system cools every heat-generating component, including the power supply, directly through a custom-engineered cooling plate, which provides a very stable temperature for all heat-dissipating components, reducing stress, extending lifetime, and with no airflow passing over sensitive electronics, environmental contaminants like dust, salt, insects, they simply never become an issue. The result is stable operation, lower room heat, and dramatically reducing the AC load. Also, the transmitter is not dependent on the HVAC system in the room. In other words, if the HVAC system fails, the transmitter will operate up to 113 degrees Fahrenheit room temperature with no issues for extended times. And this isn't just a specification on paper. This has been tested in our large climate chambers and on our campus. And as a side note, these high environmental conditions where liquid transmitters can run without issues pose an extreme challenge for those using air-cooled power supplies, which can be overly stressed at high temps, and they will fail quickly. And now let's talk about heat load. A fully liquid-cooled Rohde and Schwarz transmitter dissipates very little heat back into the room. If we look at a 40 kilowatt FM transmitter, it releases only about 1 kilowatt. A 52 kilowatt UHF transmitter, just over 5 kilowatts. And a 10 kilowatt VHF transmitter, roughly about 1 kilowatt. That reduction drives real operating savings, not just at the transmitter, but across the building. From there, the coolant moves to the stainless steel heat exchanger outside, and this is where redundancy becomes critical. Redundant pumps, redundant fans, redundant cabling. Each pump and fan can carry the full thermal load on its own, and both operate with intelligent speed control to reduce energy consumption by more than 50% when full capacity isn't required. For sites in northern climates, liquid cooling performs flawlessly. Even in deep winter, hundreds of deployments prove this, and Rohde and Schwarz has validated this performance through full ice block testing of the cooling fans. So how much maintenance does a system like this really need? Surprisingly, very little. A properly sealed, oxygen-free cooling circuit doesn't consume coolant. And if a system does require constant topping off of coolant, that's a sign of a much bigger problem and not a feature. And finally, the question station owners ask, What does that mean for operating costs? Well, beyond energy efficiency, the biggest returns come from reliability. When your transmitter stays on the air through every scheduled spot and every critical moment, well, you guessed it, revenue stays protected. And each installation is unique, but the combination of uptime, lower AC consumption, and long component life delivers measurable improvements in total cost of ownership. If you'd like to explore the performance impact for your facility, our team is ready to assist. So whether it's reliability, efficiency, service or support, Rohde & Schwarz transmitters are designed with the broadcaster in mind.